We have another example on the board. This time we are going to analyze the circuit which has 3-input NAND gate. Please notice that the first input is connected to the pull-up resistor, okay, and when the switch is open, okay, so this input is going to receive always logic 1 because current is going to go directly through the gate. So I'm going to have always 1 over here. Input 2 and 3 are connected together and both of them are going to receive the input signal. Now, so we're supposed to find the waveforms when switch is open and when switch is closed. So what we're supposed to do, always draw dashed lines at every single change of the input waveform. Okay, so when we have high at the first input and second and third input receiving at the same time zeros, okay, so any zero or at least 1 0 at the input of the NAND gate will produce high at the output. So if these two inputs are receiving 0, when this one is 1, output is going to be 1. When I'm going to have 1 at these two inputs, because let's say when time is coming and this high is present at these two inputs, I have high at first input 2, so when I have all inputs receiving 1s, output is going to be 0. So that's why I'm going to write over here 0. When the time is coming and this 0 is at the input, so this 0 will go to input 2 and input 3. Please notice that anytime NAND gate has 0 at one of the inputs, output is automatically high. That's why I'm going to have high at this time, okay? Now, if I'm going to apply this one to this input, okay, this one will go to input 2 and input 3. When all inputs of my NAND gate are high, output is low. That's why I'm going to write low over here, 0. If this 0 will come to the input, okay, anytime NAND gate is receiving 0, output is equal high. That's why I'm going to write high over here. When high is coming to the input, I'm going to have all inputs high. Output is going to be 0. When 0 is coming to the input, this 0 will bring my output to high. Now I can draw the output waveform, and please notice that the output waveform is complement of the input waveform. Okay, now we can close the switch, and please notice, if you will close the switch, the current is going to go directly to ground. You are going to short the circuit, and because ground has potential 0 volts, I'm going to have logic 0 over here. This 0, right, will bring high to the output, because if at least one of the inputs of the NAND gate is 0, output is automatically high, no matter how many inputs you have. That's why I'm going to draw logic high on my graph. Okay, so I can say that these two waves, I can say, are the solutions to my problem.